Earlier this week, we looked at vertical and horizontal asymptotes when we had rational functions in this form, 1 over x minus h plus k. The h tells us that our vertical asymptote is at x equals h, and k tells us that the horizontal asymptote has moved up. It's at y equals k. But what happens when our function is not in this format? Most rational functions are not in that format to begin with. So we're going to take a look at what that looks like. Okay, so if you were absent in class, you should take the opportunity to plug these functions into your calculator. In A, if you were to graph it, actually let me just start by putting an axis on all of these. If you were to plug it in your calculator, it would look like this. Your asymptote, your horizontal asymptote, is here at y equals 0. That's the value that your function is approaching. In B, looking at the denominator, I can tell that I'm going to have a vertical asymptote at -1. If I plug it into my calculator, it will look like this, with a horizontal asymptote at y equals 1. And actually, I should move this so it gets closer to my asymptote. There we go. All right, if I graphed C, my horizontal asymptote is at 3. And you should actually plug this in your calculator and see what it looks like. So at y equals 3, I'm going to still have a vertical asymptote at -1 from the denominator. My function, I do it in green here, will be up in this upper corner like this, and here, approaching y equals 3. Finally, this last one, D, looks pretty cool. So you should actually graph it on your calculator. We still have a vertical asymptote at -1 because -1 makes the denominator equal to 0. The rest of the function looks like this. Okay, so the question is, what is the horizontal asymptote here? Remember, a horizontal asymptote is a line that your graph approaches as you go to the ends. So as we're moving to -infinity here, where is our function going? Well, this function is actually going down, and it's going to keep going down. It's headed towards -infinity. So it's not approaching a horizontal line. Here, as we go to +infinity, as the x-axis goes to +infinity, our graph is going towards +infinity. Again, it's not approaching a horizontal line. So there is no horizontal asymptote in this situation. Okay, so the question is, how do we figure out what the horizontal asymptote is without using a graphing calculator? This table will help us determine. If you look at the degree in the numerator and the degree in the denominator, and the degree in the numerator is larger than the degree in the denominator, we call this top-heavy. And an example of that would be A, where we had D, x squared over x plus 1. The degree here is 2, the degree here is 1. So we will end up having no horizontal asymptote if our function is top-heavy. Instead, there's an oblique or slant asymptote. So in D, up above, the asymptote is actually the line y equals x. That's a slant asymptote. Okay, coming back to this table, if the degree in the numerator is the same as the degree in the denominator, we call this balanced. So example B and C up above here, These were balanced because it was degree 1 over degree 1. Here in C, degree 1 over degree 1. If we had x over x plus 1, we look at the coefficient, the a value and the b value. The coefficient here is 1. So we have 1. Y is going to equal 1 over, look at the coefficient, it's 1. So our line is y equals 1. Your horizontal asymptote here will always be your a over your b value. A is the coefficient in your numerator, and b is the coefficient in your denominator. So if we looked at the example in C, the function was, let me erase that. The function was 3x over x plus 1. 3x over x plus 1. The coefficient in the numerator was 3. The coefficient in the denominator is 1. So this is 3 over 1. And that's what we got. We had y equals 3 as the horizontal asymptote. The final example is bottom heavy, so a heavier degree in the denominator. A is an example of that. It was x over x squared. So the degree in the denominator is larger than the degree in the numerator. If that is your case, your horizontal asymptote will always be y equals 0. So top heavy, there's no horizontal asymptote. Balanced, you look at the coefficients in the numerator and the denominator. So y equals a over b, whatever a and b are. On bottom heavy, you have y equals 0 as your horizontal asymptote. All right, now it's time to do practice problems. We'll look at the first one together. In number 1, the degree is 2 in the numerator. X equals x squared gives us a degree of 2. In the bottom, we have x squared. The coefficient, the number in front of the x is 1 in the numerator, and it's 1 in the denominator. So our horizontal asymptote is y equals 1 over 1, which is just 1. All right, go ahead and try the rest of the practice problems, and then you can check your work on the key that's posted online.